Okay, so we've been talking about correlation. Now, sometimes you'll be told that the correlation coefficient, and we use R to represent the correlation coefficient. It has to be between -1 and 1. It can be equal to -1. It can be equal to 1. But it can't be below -1. It can't be above +1. And that R is going to tell me, without even looking at the graph, if we have a strong or weak correlation and if it's positive or negative. Well, should be obvious that if your R is negative, your correlation is negative. Here's the part that's not obvious. If R is between -1 and -7, we're going to say that's a strong negative correlation. Strong and negative. So from -1 to -7, that's strong negative correlation. If we got from about -7, sorry, oh my gosh, my brain, -0.7, goodness. Notice that point. My brain is not working, y'all. From -1 to -0.7, that's a strong negative correlation. From -0.7 to -0.3, we're going to say that's moderate. And it's still negative correlation. From -0.3 on to 0, that's still negative, but it's weak. So weak negative correlation. And what's exactly 0, we're going to have a special case in just a moment that we'll get to. Let's look at the positive side. I'm sure there's a joke in there about being positive. Okay, if you got an R, a correlation coefficient, between 0 and between 0 and 0.3, that's going to be weak positive correlation. If you have a correlation coefficient between 0.3 and 0.7, that's going to be a moderate positive correlation. And finally, if our R is between 0.7 and 1, you're going to have a strong positive correlation. And I said 0 is a special case. If it's exactly 0, so if it exactly equals 0, there's no correlation. Again, if your R, which represents your correlation coefficient, if your correlation coefficient is exactly 0, that means there is no correlation. Whew, okay, on to a slightly related note, but kind of different, going a little bit away from correlation. We have two new words, interpolating and extrapolating. And it's okay if you mispronounce these, because at some point in this video, I'm probably going to mispronounce them too. And I'm the teacher. I'm supposed to know these things. So we got interpolating and extrapolating. Interpolating is when you're using an equation or graph to approximate a value between two known values. So inter, I-N-T-E-R, that word root means between. So someday if you take the SAT, it'd be good to know inter means between. Okay? Extrapolating, you're going to use an equation or graph to approximate a value outside the known range of values. Another little SAT tip, extra means outside of. So extraordinary, extraordinary means outside of the ordinary. Ta-da! Your random fact of the day. Let's see some examples. Example number 1. So we got the hours a student studies and their test score. Okay? If I'm told, hey, I want to know approximately, if I study for 11 hours, what can I expect my test score to be? Well, let's look. So here's 10, here's 15, so 11 would be right next to 10. Notice that's between our points. So when you're asked to find that 11, that's an example of interpolating. Told you I'd mispronounce it. So that's interpolation. Weird word. Okay. What if we're asked, okay, what grade should I expect if I study for 35 hours? Well, if we look at our graph, here's 35 hours. This line right here. And notice that is not between 2 points on our graph. It's outside of our set. So this is an example of extrapolating. Cool. Let's look at an example with an equation. So let's say our equation is y equals 0.96x plus 51. Well, I don't know about you. I'm going to have to use a calculator. We're told that our x value is 11. I'll even show you what I put in the calculator, or at least I'll try. Oh, this should be fun. Okay, so I need to replace x with 11. So I'm going to type in my equation, but, so 0.96, oh, you cannot see that. Let's see if I can fix that. Okay, that's a little better. Ah, now you can see it. Okay, I promise that's a 0.96. You can't see the point, but I promise it exists. 0.96, then put parentheses around our x. They said our x we want that to be 11. And then the rest of our equation is plus 51. And we should hit enter, and we get 61.56. And that's what we're going to write on our paper. So 61.56. Fabulous. So we are able to find it by just plugging in our value for x. Okay, if you're given a chart, it's a little different. So weird chart, I know, I picked an odd one. So we're told if someone's arm span in centimeters is 155 centimeters, then their height might be about 163 centimeters. So that's what this information is. So if we're told, okay, I want to know if my arm span is 156 centimeters, what could I expect the height to be? Well, we got 155, we got 157. So that means our height needs to be between 163 and 159. So I would guess 161. And this is an example of interpolating. Because notice we went between 2 points. Okay. If I have an arm span of 180 centimeters, I want to approximate my height. Notice here's our highest point, 178. We got to go past it. So I'm going to estimate we have to have something above 174 since this is going up. I'm going to say maybe 178. And that's an example of extrapolating. Awesome. One last topic. Okay, our last topic is linear regression for today. And linear regression is how we find an equation for the best fitting line. So if you're given a graph, you can draw the line that is best fitting. But if you're given a chart, we can use our calculator and get an equation, an actual precise equation. So let me show you how to do that. So we're given a chart, and you should have a paper that looks like this. We are going to just follow these steps. Unfortunately, I can't fit everything on here. So have this paper out, follow along with me. Okay, we got our handy dandy calculator. So from the home screen, so first click home. Okay, we need to select a new document. So I'm going to click 1 for new document. And no, I don't need to save this. Okay, step 2 says add lists and spreadsheets. So click the number 4 on your keypad to add lists and spreadsheets. Then it says type X in the A box. That means we're going to click up so that we have our bold line around that A. and it tells us to type the letter X in. Wonderful. To get out of that box, I'm going to click down. Step 2, we need to type Y in the box labeled B. So I'm going to go to the right one, up one, type Y. To get out of the box, click down. Then we need to fill in our table. So here are the values we have. So I'm going to go down to the left. I'm going to put in all my X's first. So we got 1, next value 2, down, next value 4, down, 8, down, 9. Beautiful. I have all my X's. Now I need to go over to the right. Or you know what? I'm going to go up because my calculator is being a punk. Go up, back to the top of my list, go to the right. Now we're going to put in our Y's. So notice we're in the Y column. We got 33, down, 35, down, 40, down, 46, down, 50. And I'm going to go up because apparently my calculator doesn't like to go to the side. Alright, now we're on step 5. It says to click menu. So I'm going to click menu. Then I need to choose statistics, so I'm going to press the button number 4. Then I need stat calculation, so I'm going to click 1. And I want linear regressions. Make sure you pick linear regression. That's mx plus b. So that's number 3. Alright, now we're on step 6 on our paper. It says type in for X list, put X. So, hey, our cursor's already there. We're just going to type X. Then I'm going to click down. And then for Y list, we want Y. Then I'm going to click OK. Well, again, if my calculator likes me, you punk. Okay, maybe not. I'll just click down until I get to OK. Which is the painful way to do this, but okay, there we go. Hey! And then click OK. Fantastic. Look at this. Something popped up. Yay. If we look, it's telling my M is this number right here. And it's telling me B is this number right here. So that means our solution, we found the equation. So I'm going to write to the side. So we chose y equals mx plus b. So I have y equals. Here's my m. So I'm going to round that off because that's kind of long. I'm going to say that's about 2. So y equals 2x. Alright. And here's our b. I'm going to round that, say 31.18. So 2x plus 31.18. There we go. We found our equation. Let's do one more example. Okay. So we're doing the same exact steps. I'm going to go back home. I want to click New Document, so that's number 1. No, I don't need to save this. Let's add a list by clicking 4. Go over to the box labeled A. We're going to type the letter X in there. Go down, to the right, up, type Y. Go down 2, and to the left, let's start typing our X's. We have -4. Make sure you click negative. So click this button, negative. Not minus, but negative. -4, -1, 0, 4, 6. Then click up, 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 up. We go over, let's put in our Y's. We got 22, 16, 15, 13. Oh, made a mistake, so click delete, then 13. And 9. Fabulous. We got everything entered. Alright, we're going to click menu, then choose statistics, then stat calculations, click 3 for linear regression. Our X list is X, our Y list is Y. My cursor doesn't want to pop up. Oh, there's my cursor. Alright, I'm going to click OK. I don't know why it has a black box on it. Whatever. Okay. Yay! Here's my M. So my equation is going to be, let's see if I can fit this all on the screen. Y equals, oh no, pen, don't die on me, punk. Hey, Y equals negative, I'm going to say 1.14, leave it at that. Don't forget your X. We need to add in our B. I'm a B. Our B is, let's see, positive 16.14. That's about good enough. Woo! We survived the very long video. Okay, we have some practice to do. Get to it.